In this video, I will talk about complex numbers. We will talk about how to add, subtract, multiply, and divide complex numbers and perform operations with square roots of negative numbers. Before, when we talked about square root of negative numbers and solving equations, we would say that there was no real solution or not a real number. That is still true. However, we're going to introduce a new set of numbers which will be called the imaginary numbers, and it would include an imaginary number called the letter I. So the imaginary unit, written as I, is the number whose square is -1. That is, I squared is equal to -1 and I is equal to the square root of -1. The set of all numbers in the form of a plus bi with real numbers a and b and I being the imaginary unit is called the set of complex numbers. You will write in standard form a plus bi. Now when you take my test or quiz, I don't care if you write it as bi plus a. In my math lab, they want you to write it as a plus bi, but if you switch it, it'll still accept the answer. So first, let's talk about adding and subtracting complex numbers. Remember, a is a real number and bi will be the imaginary number. So if you said b equal to 0, you're going to be left with a, and a is a real number. And if you said a equal to 0, you're going to be left with bi, which is an imaginary number. So when you add or subtract complex numbers, what you do is you group the real numbers together and the imaginary components together. Same thing with the difference and with the addition. So if we go through a problem, we have 4 plus 6i plus 3 minus 2i. So once again, I am going to group the real numbers together and I'll group the imaginary numbers together. So I get 4 plus 3, which is 7, and then 6i minus 2i is 4i. So once again, in my math lab, they want you to write it in this form, a plus bi. They want you to write the real number first and then the imaginary component after. However, if you write it like this, it would not mark it wrong. Let's look at the next one. We have 8 plus 2i minus 4i. So 8 is by itself, so I don't have to group it with anything. But I'm going to take the 2i minus the 4i. I'm left with 8 minus 2i. The next one is 5 plus 2i plus 4 minus 3i. Once again, group the real numbers and then group the imaginary numbers. We get 9, and then 2i minus 3i is a -1i, or you can just put -i or minus I. The next one is 6i minus 2 minus I. So you got to be careful here. You're going to distribute this negative sign throughout this set of parentheses. So distribute negative sign. So we're going to change all of the signs in the parentheses. So this will be minus 2 and then plus I. We can go ahead and group 6i plus I is 7i. And then you got the minus 2 or -2. Your answer would be -2 plus 7i. So I do have a couple of you try problems. I'm going to have you try that on your own. I did go over this in the classroom. But the answer here will be -10 plus 7i. And the answer here would be 8 plus I. So I'll have you figure this out. I just wanted to save time on my video, so I won't go over those steps. The next part talks about multiplying complex numbers. The first thing you need to remember is when you take I squared, if you multiply I times I, that gives you I squared. I squared simplifies to -1. So in this first problem, we have -5i times 3i. So I'm going to take -5 times 3 and I'm going to take I times I. We get -15 I squared. Remember, I squared simplifies into -1. So a negative times a negative will give you a positive 15. In this next problem, we're going to distribute the -2i throughout the parentheses. So I get -2i times 6 plus -2i times -2i. This gives me negative 12i plus 4i squared. Don't forget that I squared is negative 1. So your final answer is negative 12i minus 4. If you wanted to, so this is the bi plus a way, or you can write it as negative 4 minus 12i, which is the way they want you to write it in my math lab. In this next problem, we're going to use the FOIL method because we are multiplying out two binomials. So this will be 3 times 6 times 3 times I times negative 4i times 6, and then negative 4i times I. So when we multiply it out, we get 18 plus 3i minus 24i minus 4i squared. I'm going to go ahead and simplify these two. I'm going to combine those. That gives me a negative 21i. And don't forget that I squared simplifies to negative 1. So now if we simplify it further, I get 18 minus 21i plus 4. Now I can take the 18 plus 4 and add those together. That gives me 22 minus 21i. This next problem is also a FOIL problem. We're going to multiply first, then the outer, then the inner, and then the last. So I get 36 minus 30i plus 30i minus 25i squared. Negative 30i plus 30i gives me 0, and I know that I squared is negative 1. A negative times a negative will make this a positive 25. We're going to add that with 36, and we get an answer of 61. In this next problem, we're going to FOIL twice. We're going to FOIL this part, and then we're going to FOIL this part. So if I do this first part, I'm going to multiply it out. I get 6 minus 6i minus 5i plus 5i squared. So right now I'm only working with this first set of parentheses. So when I do this, this simplifies to 6 minus 11i, and I squared is negative 1. So I get 6 minus 11i minus 5. 6 minus 5 is 1 minus 11i. So that's for the first set of parentheses. Now I'm going to go ahead and multiply out the second set of parentheses. I get 4 plus 2i minus 2i minus I squared. 2i minus 2i is 0, and we know I squared is negative 1. So now I have 4 minus a negative 1, which is 4 plus 1, which is 5. So now I'm going to put it all together. I have 1 minus 11i minus the second set of parentheses multiplied out to be just 5. So I have 1 minus 5, which is negative 4, minus 11i. I have you try problems here. I'll go ahead and let you work those out. I'll put the answers up here, 63 plus 14i. And this next one is 58 minus 11i. Now we're going to talk about dividing complex numbers. For the complex number a plus bi, we define its conjugate to be a minus bi. When you take the product of a complex number and its conjugate, you're going to get a real number. So, once again, if you have a plus bi, the conjugate is a minus bi. So what you do is you change the sign in the middle. So when you multiply a complex number with its conjugate, you're going to get a whole number. You will not have any i's in your final answer. So if you go back up to this problem here, this one here is an example of multiplying the conjugate. You got 6 plus 5i times 6 minus 5i. As you can see, when we multiplied it out, we got a real number. We got 61. There were no i's in our answer. So when we're dividing complex numbers, you're going to use the complex conjugate of the number we're dividing by. So the goal of a complex number division is to obtain a real number in the denominator. Okay? So we're going to multiply the numerator and the denominator of a complex number quotient by the conjugate of the denominator to obtain this real number. So basically, we're going to divide the denominator. When we divide the denominator, you would not have any i's in the denominator. You're going to have a real number, and you'll see in a minute. So in this first problem, we have 3 plus I divided by 2 minus 3i. We're going to multiply top and bottom by the conjugate of the denominator. So our denominator is 2 minus 3i, so the conjugate would be 2 plus 3i. So what I'll do is I'm going to multiply top and bottom by the conjugate of whatever my denominator is. So if I multiply out the numerator, I have 3 plus I times 2 plus 3i. So basically you're going to FOIL this just like we've been doing. So I get 6 plus 9i plus 2i plus 3i squared. I'm going to go ahead and simplify this. This is 6 plus 11i plus 3 times negative 1. We know that 3 times negative 1 is a negative 3. So we get 3 plus 11i in my numerator. So it's all right for you to have an I in the numerator, but when we do the denominator, your I should disappear. Okay, so when I do this, I end up with 4 plus 6i minus 6i minus 9i squared. We know 6i minus 6i is 0. I'm going to be left with 4 minus 9 times negative 1. That's 4 plus 9, which is 13. So now we're going to put everything back together. My numerator is 3 plus 11i, and my denominator is 13. You cannot write your answer like this in my math lab. They want you to split it up. So it'll be 3 over 13 plus 11i over 13. Okay. If you write it 3 plus 11i over 13, my math lab will mark it wrong. So make sure you separate it. Let's look at another problem. The conjugate of the denominator is 4 minus 2i. So I'm going to multiply top and bottom by 4 minus 2i. When I do the numerator, I have 2 plus 5i times 4 minus 2i. I'm going to go ahead and multiply that out. I get 8 minus 4i plus 20i minus 10i squared. Going to simplify this. Negative 4i plus 20i gives me 16i. And then minus 10i squared, you know, I squared is, negative 1. So a negative, this is a negative in front of a negative makes this a positive. So we get 8 plus 16i plus 10, which would give me 18 plus 16i. Now let's do our denominator. When we do our denominator, our I should disappear. We get 16 minus 8i plus 8i minus 4i squared. Negative 8i plus 8i disappears. That gives me 16 minus 4 times negative 1. A negative in front of a negative would be a positive, so we get 20 in our denominator. So there's a little trick here for this one. When we put it all together, we get 18 plus 16i over 20. but we have to split it up. So it's 18 over 20 plus 16I over 20. You're going to have to reduce your fractions. Reduce your fractions, please. So this reduces to 9 over 10 plus 4I over 5. If you don't reduce your fractions, my math lab will mark it incorrect. So I have a you try problem here. You can go ahead and try this on your own. I get 16 over 7 plus 21I over 17. I'm sorry, 16 over 17 plus 21I over 17. Now we're going to talk about how to perform operations with square roots of negative signs or negative numbers. So if you have the square root of negative b, it'll simplify into I square root of negative b. And that's because we're going to split this up. I'm going to bring this negative out, and I'm still going to keep it under the radical sign. The square root of negative I, if you remember the imaginary rules, would be I. And then we have the square root of b. So that's why this simplifies into this. So let's look at this first problem. We have the square root of negative 25. I'm going to split this up into the square root of negative 1 and the square root of 25. The square root of negative 1 is I, and the square root of 25 is 5. So your answer is 5I. If we do it with this next problem, we have the square root of negative 1 times the square root of 3. Once again, the square root of negative 1 is I. We cannot simplify the square root of 3. We leave it as is. The next one is negative square root of negative 50. I'm going to split this up. I'm going to bring this negative out, and I know 50 can be broken up into 25 and 2. So you want to split it up into numbers or a number that you can take the square root of. So this ends up being negative I. Square root of 25 is 5, and then the square root of 2 you cannot do anything with. So your final answer is negative 5I square root of 2. Now we're going to perform some operations where we have a negative underneath the radical, but we're going to simplify that first. So in this first problem, we have negative 3 minus the square root of negative 100 squared. So we're going to have to FOIL this out, but first I'm going to simplify the square root of negative 100. The square root of negative 100 we're going to write as negative square root of negative 1 times the square root of 100. We know that the square root of 100 is 10 and the square root of negative 1 is I. So now we can write the problem as negative 3 minus 10I squared. And then we can go ahead and FOIL this out. We're going to write this out twice because it says squared. And we can go ahead and multiply this out. Negative 3 times negative 3 gives me 9. Then I have 30I plus 30I plus 100 squared. I know that 30I plus 30I is 60I. And I know that I squared is negative 1. So this gives me 9 plus 60I minus 100. 9 minus 100 will give me a negative 91 plus the 60I. If we look at this next problem, we have negative 16 plus the square root of negative 8 divided by 20. So I'm going to simplify the square root of negative 8. I'm going to write it as negative 4. I'm sorry, no, that's not what I want to write. I'm sorry. I want to write it as the square root of negative 1, square root of 4, square root of 2. I know that square root of 4 is 2. Square root of negative 1 is I. And we're left with the square root of 2. So now when I write it, I have 2I. I have all this all over 20. But we have to split it apart and we have to simplify our fractions. So when we simplify, negative 16 over 20 simplifies to negative 4 over 5. And then 2 over 20 will simplify to 1 over 10. But don't forget, we still have an I here. You don't have to write the 1, but it'll be I square root of 2 all over 20. So this will be our final answer. So I do want to emphasize that when you do it in my math lab and you have fractions, split it up and see if the fractions reduce. So I have a you try problem here. I'll go ahead and let you work that out on your own. I get an answer of 7i square root of 3 for this first one. And then for the second one, I get negative 5 plus 12i. Okay, that is the end of the lecture.